Welcome to our favorite YouTube channel DCD Electrical Knowledge. Today's goal is to learn to solve some important numerical problems related to electrical power and energy. Recap. Power P is equal to V into I, and V is equal to IR and I, that is I square R, and according to Ohm's law V is equal to IR, so I is equal to V by R, then V square by R square into R, that is A square by R. Okay, next, energy, 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 E is equal to power P into time T, that is energy is equal to power multiplied by time T. Let us start question number 1. In an electric field, the potential of 2 points are 400 volt and 1000 volt. What is the work done when 3 into 10 to the power minus 8 coulomb charge into 10 to the power minus 8 coulomb charge bring from one point to another? Let us see, in an electric field, that is 2 points A and B in an electric field, Q charge, that is 3 into 10 to the power minus 8 coulomb, bring from A to B. So that what is the work done? We know that work done W is equal to potential difference PD into charge. Now, what is the PDs here? Now, difference between 2 points of potential difference, 1000 minus 400. 100 volt into charge 3 into 10 to the power minus 8 coulomb. So it comes 600 volt and 3 into 10 to the power minus 8 coulomb. So it comes to 3 multiplied by 6, 1800 multiplied by 0 10 to the minus 8 coulomb and volt. So this unit is work done joule. So it comes to 1.18 into 10 to the power minus 6 joule. So 3 into 10 to the power minus 8 charge brings from one point to another point, that is potential difference is equal to 1000 minus 400 multiplied by charge q. So the work done becomes 18 into 10 to the power 6 joule. Question number 2. A bulb is connected with 220 volt supply main and draws 1 ampere current. Well, a bulb is connected with 220 volt supply line and subsequently the bulb draws 1 ampere current. But how much current will be drawn when that bulb is connected is to be connected is to be connected to be connected with 110 volt supply line main. Okay. Now how we can say easily to solve the problem? Procedure is that given data is V1 is equal to 220 volt and draws the current, that is I1 is equal to 1 ampere. Okay. Now, according to Ohm's law, we know that V1 is equal to I1 R. According to Ohm's law. Clear? So V1 is equal to 220. I1 is equal to 1. So R is equal to 220 ohm. Clear? Now this bulb is connected with V2, that is 110 volt. But it also be remember that the resistance of a bulb remain constant. So it is denoted by R. That is R is equal to 220 ohm and I2 is to be find out. Again, according to Ohm's law, we can say that V2 is equal to I2 into R. This R is remains same as the bulb is same bulb. So V1, V2 is equal to 110 and I2 multiplied by 220. So I2 is equal to 1 by 2, that is 0.5. Okay, this is very easy, but this concept is very important. The resistance of a bulb is remains constant whenever it may be used either 220 volt or 110 volt. Hope it is clear to all. Question number 3. Find the ratio of resistances of two valves to bulbs having SPECI, specification of 220 volt 60 watt and 110 volt 60 watt. Find the ratio of resistances of two bulbs having specification of 220 volt 60 watt and 110 volt 60 watt. Now we shall try to solve the question. The specification of two lamps are given. Now we know that power P, power P is equal to V multiplied by I. V multiplied by I. That is, here voltage is given. So we can write this formula in terms of voltage, that is V is equal to, instead of I, V is equal to IR, I is equal to V by R. So we can write V by R, and then it comes to V square by R. Clear? This is clear to all. Now we can write R is equal to, that is, it is the general formula, and we can write it R1 is equal to V1 square by P1, right? From this formula, it can be right R1 is equal to V1 square by P1. This is the main formula. Then the resistance of this lamp is 220 multiplied by 220 divided by 60. Hope it is clear to all. Similarly, we can write also, similarly, R2 is equal to V2 a whole square divided by P2, and put this value, V2 is equal to 110 to 110 divided by 60. This is 1, this is 2 equations. Now we can divide these 2 equations, 1 and 2, and we get 1 divided by 2. We can get R1 by R2 is equal to this value, 2 into 2 divided by 60, then 110 multiplied by 110 by 60, that's equal 2 divided by 2 divided by 110 multiplied by 2. It has no unit, that is resistance, and resistance is out. Okay, so 2, that is 4 by 1. Now we can write R1 is to R2 is equal to 4:1. This is the very important, and the ratio of resistance becomes 4:1. So if a bulb is used low voltage rating, then resistance will be greater. Okay. Question number 4. This is the figure. Lamp 1 and lamp 2. Resistance 55 ohm, and it has also resistance 55 ohm. These two series connected lamps are connected with 220 volt. Then find the power spent in each bulb. Okay. Now supply voltage is given and resistance of each lamp are also given. Now we can write, since the two lamps are connected in series, so equivalent resistance are equivalent is equal to summation of 55 plus 55 ohms, that is 110 ohms. And V is equal to, given data V, supply voltage is equal to 220 volt. So what is the current flowing through the circuit? According to Ohm's law, we can write V is equal to I into R, equivalent. According to Ohm's law. Then 220 is equal to I multiplied by equivalent resistance 220, 110. 110. So I is equal to 220 by 110, that is 2. It also be noted that the symbol used, the conventional symbol used for resistance, voltage and current. The used symbol carry the conventional meaning. The used symbols carry the conventional meaning. Okay. Then what is the formula of power consumption or power spent? We know that P is equal to VI, but or I square R or V square by I. In previous lecture, I also discussed that which formula is used when in this circuit same current is flowing through the two lamps because it is series circuit. Since we can use the formula of I square R, so we can use this formula 2 square multiplied by 1 110. I square R. But according to the question, each lamp. So this value of resistance power, so power spent for each bulb P is equal to R should be 55. 55. What? That is 4 multiplied by 5 watt. That is watt. What is this? Okay. Power consumption of each bulb is watt. Question number 5. A bulb of 220 volt 100 watt is connected with 110 volt, 110 volt. Find the new power. Okay. According to this question, we can see that a bulb of 100 watt 220 volt is used 110 volt. What is the new power of that bulb? Now, we know that power P is equal to VI, that is I square R or V square by R. Okay. Then, since the V is given, now we can put the value of V to 220 V square by R. And P is equal to 100. So we can find R is equal to 220 by 100, that is 484 ohm. Clear? So the resistance of the bulb is 484 ohm. Now this bulb, that is 484 ohm resistance, is connected with 110 volt and find the power. Then we can find the power P is equal to, according this formula, V square by R. Now put this value. Power is to be find out. So V is equal to 110 into 110 by 484 watt. it becomes 25 watt. So the valve that consume 100 watt when used 224, and the same bulb when used in 110 volt, the power is to be 25. So it is clear that at low voltage the power consumption of the bulb is to be minimized, is to be reduced. Okay, hope it is clear to all. This question is very important. Question number 6. A fan of 100 watt runs with 5 hours. Find the energy consumption. Find the energy consumption. Okay. What is the given data? Power of fan P is equal to 100 watt, and time time P is equal to 5 hours. According to the formula of energy, we know that energy is equal to power into time. So put the value P is equal to 100 watt and time is equal to 5 hours. So this watt can be converted to kilowatt and hour 5. So we can write 5 by 10 kilowatt hour, that is 0.5 kilowatt. So energy consumption is 0.5 kilowatt hour. In this question, if we add, what is the monthly energy consumption? What is the monthly energy consumption of this stipulated load? Energy consumption. Then we can write monthly energy consumption, monthly energy consumption is equal to kilowatt hour kWh into 30 days. So 150 kilowatt hour, that is 15 unit. 1 kWh is treated as 1 unit. Okay. Next, this question can also be extended, but how? Now we see that what is the monthly energy bill? Say, given unit tariff given tariff is tariff means rate rupees 10 per unit. So monthly bill will be monthly bill is equal to 10 into 15. Rupees 10 into 50 units, so rupees 150. Okay. Hope it is clear to all my beloved student. This is very important concept, and we can use this formula at our house to the paying the bill for the electric supply companies. In this way, monthly bill or quarterly bill is calculated. Do like, share and subscribe my channel. No more today. Thank you.